thing. So anybody that missed it, you can tell them, hey, go back and look, it's there. Let's see, is that recording? It is. Come on, record. Internet. So what did Mr. Piney go over on? What did Mr. Piney go over on the handhelds, on the Hart communicators? Did he talk about online mode versus offline mode? Okay. Did he talk about putting something in service and taking something out of service? Okay. Was everybody successful being able to switch those temperatures from one temperature to another?
Yes, sir.
Okay. Let's see here. Y'all know about none of this stuff gets set up and sent to the transmitters until you hit what? Send that data. That's right. Okay. If I had a bunch of these transmitters in the office and I went to set them up in the office, but I didn't install them, somebody else took them out there and installed them, would that work? Can I set these things up on a bench in the office? If I had a transmitter and a Hart communicator, can I set it up on a bench in the office and have somebody take that thing out and put it in play? The answer is yes. Charles, I don't know if you're talking. Your mic's off. It looks like you're wanting to talk, but your mic's off. You can do that. What if I don't have the transmitters? I've got the Hart communicators, and I've got to drive out in the field, but I don't need to go out in the field for 2 weeks because they're not going to have them installed yet. Is there anything I can do on the handheld for that 2 weeks, between the time I go out there and now? You can put it on the line, right? What do you mean by that? Like, say that a different way. Like, connect to them from anywhere. They're not even installed yet. How are you going to connect them if they're not installed yet? Who said that last piece there? Who was that? Save it and send it. So Brandon's right, but what I'm looking for there is the term offline mode. You notice when you turn that thing on, it'll tell you online mode, offline mode. Offline mode will allow you to save. You'll be able to save in the memory of the Hart communicator. And when you save in the memory of the Hart communicator, then you could give that to somebody else and say, look, I saved the file under whatever, take it out there and download it when that thing is installed. That's how that works. Did y'all talk about how to take over a piece of equipment and send it a 4 to 20 milliamp signal in lab? Okay, so there's a way, if you go, did y'all go to the back of Delta V and plug into anything? You can go in and basically take over the signal. You can change the output and change the signal to the device and make it think, like if you had let's say you've got a level transmitter that's 0 to 100 inches. That's a 4 to 20 milliamp signal, right? 0 inches would be 4 milliamps and 100 inches would be 20 milliamps. You can override that signal with the Hart communicators and tell it, look, that's for, to fake it out. You can basically put it in service or out of service and tell it, look, this is 12 milliamps, and you're lying to the device. You're lying to the system because you have told it with the Hart communicator, no, I don't want 4 milliamps or 20 milliamps. I want it to be 12 milliamps, and you can lock that in. Remember, everybody in this class did the labs, the pressure labs that we have in 1355. Yes. That's yes, right? Everybody did that. So do y'all remember when we would command the I2P from 0 to 100%? Do you remember what would happen if we had built our blue blocks on the screen and it would say, whatever percent? Remember how it would say operator, OPER? What you're doing with that handheld is putting that device in OPER. You're putting it in operator. You're telling it, look, this is how many milliamps you've got. So you're essentially overriding the system. You're overriding that one piece of equipment with that Hart communicator there. Now, the smart equipment, like a smart transmitter, if you tell it, look, set your value to 12 milliamps. So now you're going to think you're 50 inches of water. If you don't release that value and take it, quote unquote, out of operator, then when you walk away and you drive back 2 hours back to the shop, and then you realize, oh man, I don't know if I released it. That device is still at 50%. It's still at 50 inches of water. It's at 12 milliamps, which is a massive problem because you have a process that's either flooding right now or it's completely empty. And you have to be aware that the Hart communicators give you the ability to do that, okay? Everybody understand that? Yes, no? All right. I'm going to move forward. Did y'all get into, y'all did get into calibrating stuff with the Hart communicators, yes? All right, good. I can skip that. Did y'all bring up, did anybody bring up, Mr. Piney or Mr. Martin, did they bring up smart transmitters at all? Or was it just Hart communicators? I'm guessing that it was just Hart communicators because nobody said anything. Am I right? Okay, so here's something kind of didn't do much. I don't know how to read into that, Brandon. Y'all just maybe referenced it a little bit. I don't know. Okay, so here's the thing that you're going to need to know about smart. Let's talk about just a smart pressure transmitter. Stand by one second. Let me grab one real quick. All right, everybody makes one. Okay, all these different vendors, they all have their own version, but they are Hart protocol, right? Hart communicator protocol. I don't know if you can see that. I'm gonna see if it'll focus. It won't focus, but there is this camera sucks. Whatever. Can you tell that there's dip switches here? You can see the dip switches. These are little switches up and down, basically, right? And then right across here, where my finger is, there's a table. That table basically has information, and it's going to tell you if you take switch up or down, because it's an on or it's an off, right? Digital switches. It's either a 0 or 1. On the back of this, and this is part of the Hart communicator. This will be stuff that's included in the Hart communicator test, because there's a little bit of information that talks about smart transmitters, okay? In these smart transmitters, there's some dip switches on the back, and there's a couple of very important dip switches. You can basically write enable and write protect this device. So if I turn off switch 5, this one has a total of 6 switches on it, okay? Switch 5 and switch 6 have a unique job to do on this device, okay? Switch 5 is what we call a write enable. Let's say that I'm working in a facility. Did I ever tell you about the time or how I used to carry around fingernail polish and why I carried around fingernail polish? So that I could go over my 0 and span screws and know that if that seal was cracked on that somebody had messed with my stuff. Well, these devices have an electronic version of that. You can take switch 5 and put it to the 0 spot, push it down, and it will write enable this. So if you try to talk to this thing, if you try to plug into this with a Hart communicator, You can see all the values in it, but you can't change anything. You can't change the span of it. You can't zero it. You can't change degrees Fahrenheit or inches of water or whatever it is, that whatever the device is. Write enabled, and I don't mean write as in right hand. I mean WRITE. You can't write any information to this device. And what happens a lot of times when you're using the Hart communicators is you can still talk to it. The Hart will still pop up in the top right corner of the display. You'll still see that little heart icon, meaning that you're communicating with it. But when you try to send data, it won't take it. And you're going to think that you've done something wrong, like you have something connected wrong, or you didn't hit send data, or whatever the case may be. The number one thing that's going to bite you is the fact that this dip switch is turned on. And if this dip switch is on and the write enabled is turned on, you can't write anything to it. So you have to turn that off. Out of all the sensors that are out there, the smart transmitters, it might not always be switch 5. This table, which you cannot see, that table up here, it has it spells out what switch 1 does, what switch 2 does. Well, on a Fisher or a Rosemount or whatever else, switch 1 might actually be the right enable. So there's a table back here that you're going to need to look at to see what it is you need to turn on and off, okay? So there's that one piece, right? You need to know that exists, that's a thing, that the write enable is a thing. All right, there's also, this is another one of the test questions, right? And I don't know where this is in it's page 45 in this document, right? So page 45 here. One of those jumpers on there is a fail-safe jumper, the dip switch. I shouldn't call it a jumper. It's a dip switch. That jumper, that dip switch, if the pressure, let's say that this device was set up for 0 to 30 psi. So this thing is set up to read 0 to 30 inches of water. Okay. No, let's go psi. It's 0 to 30 psi, and I put 40 pounds of pressure on it. That's going to be more than 20 milliamps, right? 0 to 30 psi, 4 to 20 milliamps. If I put 40 on it, that's going to drive it over 20 milliamps. It's going to fail the device because this thing doesn't do real well when you give it more pressure than it needs. That diaphragm doesn't have the room to move. It's not built for that. So that last dip switch, the failure mode dip switch, which is what we want to talk about now, that failure mode dip switch says, if I get more pressure than X amount, do you want me to fail my milliamp signal down to below 4 milliamps or up above 20 milliamps? So on page 45, they call it the failure mode alarm, and I doubt, maybe some of you printed this out, maybe some of you haven't, I don't know. As part of its normal operation, the device, the transmitter, will continuously monitor its own operation. This automatic diagnostic routine is a time series of checks repeated continuously. If the diagnostic routine detects a failure in the transmitter drives its output either below 3.75 milliamps or above 21 milliamps, depending on the position of the internal jumper or dip switch, okay? Now, if I ever put a meter on it and read 3.75 or 21 milliamps, immediately that tells me that I've got some other issue, because we've told this thing, look, I want you to fail up or I want you to fail down. So either you've got too much pressure on you, you've got a negative pressure, because this thing is designed 0 to 30, not -5. So it could have actually a vacuum on one side of it, and that would cause a failure. This device would give us, based on that jumper, based on the dip switch, 3.75 milliamps or 21 milliamps, because the working signal, the working range of the device is what? 4 to 20 milliamps. So it goes outside of that range and says, look, be stationary at this value, so that they know if they plug a meter in, that's the problem. Now, you don't have to plug the meter in, because you could take the Hart communicator, get anywhere on that wire, and if you read 21 milliamps there, immediately there's a problem with the device, right? Y'all talked about that. You can plug in anywhere on that wire to talk to these devices. Okay? Everybody kind of get where we're going with those two switches? One is a write enable, write protect. The other one is a failure mode alarm. Okay. I think that's it. I think that's it, guys. I think that's all I want to cover for the Hart communicators. And then there's like a little bit of stuff there with the smart transmitters. Do y'all have any questions about any of that stuff that we talked about just with the Hart communicator and the transmitter? If not, I'm going to go ahead and stop the recording, and then I'll post this version or this piece of it to the thing for the other group. Everybody good? Okay, let me stop.
Yes, sir.
All right, let me stop that real quick. Let's see here. Stop recording.